Hello there. We are on STAT-5. This is called two-way frequency tables, okay? Why two-way frequency tables? Because we have different portions of data that we're looking at, okay? So we're looking across this row. We're looking at eye color, okay? So across the row will give you a total of the eye color of these people. So across this row, having blue eyes, there's 8 people who have blue eyes, 7 people have brown eyes, 5 people have green eyes, okay? So that's one way. And then the second way, aka two-way, is down this way, okay? So they're columns. So it's hair color. So down this column will tell you the total amount of people who have black hair. So 9 people have black hair, 7 people have blonde hair, 4 people have red hair, okay? So we have columns and we have rows, okay? And then we combine them like a Punnett square to figure out the specific details of somebody who has red hair and blue eyes. Okay, so if something asks you red hair, you go down the column of red hair and across over to blue eyes if that's what they're asking you to find. Alrighty, so these are a little tricky. The warm-up is just for you to do. And let's get into what we actually have. So a class of 20 students recorded their hair color and eye color, which are shown in the two-way frequency table. I just explained to you what a two-way frequency table is. How many students had blonde hair and blue eyes? Okay, so what I'm trying to do is look for blonde hair. Okay, so this is the column that has blonde hair. Okay, but I want to combine that with blue eyes, and this is the row that has blue eyes. So when I combine blue eyes and blonde hair, I'm left at this number 4. Okay, so this would be 4 people. Okay. Secondly, this is asking you how many students have red hair. So it is not dependent on eye color at all. It is strictly asking you about hair. So if I'm only asking you about hair, notice how I'm only asking you about this column, not the row, because I'm not asking you about eye color. So red hair, I'm going to look at the red area, and the total number of kids have red hair is all of these added together, which is 4. So 4 people. Okay. Alrighty. Some of them get a little bit more complicated, and we're going to see that. So let's construct a table that shows joint relative frequency and marginal relative frequency. Okay, so frequency is something that's happening, how often something is happening. Okay, so out of like how many times out of a total is something happening. Marginal relative frequency, that's when you're going to take the total out of the total. And joint relative frequencies are just these inner boxes. Okay, so I guess we can say inner box number divided by total sample. Okay, oopsies. So basically what we're saying is we'll do these ones in this color. It's all of these. So these are my joint relative frequencies. As opposed to, let me see if I know the color. Where my marginal relative frequencies, that's when you're going to take the total out of the total. Okay, so that's these things right here. Okay, so we're going to do these in this color. And this is total amount over total sample. Okay, and what we do is we're just going to find them up here. All right, so joint relative frequencies, what happens when these two things join together and make a joint? okay? And they join together, and how often does it happen, okay? So how are they related when they join out of a total? So for this one, I have 3 times that this joining happens, that the black hair joins with blue eyes, out of my total sample, which is 20, okay? So I'm going to have 3 divided by 20, which is 0.15, and I'm going to turn this into a percent by timesing it by 100. So this is 15%, okay? All of these are going to be the same thing in here. So I'm going to have 5 divided by 20. Okay, 5 divided by 20, times 100 is 25%. Okay. Green, I have 1 joint that has black hair and green eyes out of 20. So 1 divided by 20 times 100 gives me 5%. Okay, I'm going to go back up here because I'm staying with my joint relative frequencies. I have 4 out of 20. So 4 divided by 20 times 100 equals 20%. 2 out of 20, times 100 is 10%. 1 out of 20, well, we already have that, is 5%. And red is also 1 out of 20, which is again 5%. 0 out of 20 is 0%. And this one down here is 3 out of 20. 3 divided by 20 times 100 is 15%. Okay, so those are my joint relative frequency. My marginal relative frequencies are going to be the totals out of the total sample still, okay? So I would have 9, and my total sample is still 20. 9 divided by 20, times 100 is 45%. This one is 7 out of 20 times 100 is 35%. And this one is 4 out of 20, which is 20%. Okay, and my totals down this way, I'm going to have 8 out of 20 times 100 is 40%. I'm going to have 7 out of 20, which we already looked was 35%. And this one is 5 out of 20, which we've had before as 25%. Okay, and what's important is this total should add up to 100%, and this should add up to 100%. So if I have 40 plus 35 plus 25, this better be 100%, okay, which it is. So 40 plus 35 plus 25 is 100. If I come across this way, I get 45 plus 35 plus 20, also 100. So you are always looking at 100% of your sample, okay? All right, let's get into the more complicated stuff. So this is the last exercise for today, exercise 2, and this should say 3. Okay, so now what's happening here is we are going to talk about if there's a connection between eye color and hair color by using conditional frequencies, okay? What does conditional frequency mean? This is equivalent, so conditional means that something is being kind of reliant on something else. So just because Miss Lyons has blonde hair, does that automatically mean she has brown eyes? Or Miss Martin has blonde hair, does that automatically mean she has blue eyes? Okay, so there's conditions on the data. So what gets confusing is how you read these things. So what is the conditional relative frequency of having green eyes if you have red hair? okay? Green eyes if you have red hair. So what you're looking at is the total sample of students who have red hair and how many of them have green eyes, okay? So let's look at how many students have red hair, okay? So red-haired students, there are 4. So I'm going to put this in a sentence so it's a little bit more clear for us right away. There are 4 people with red hair. Okay, so green eyes if you have red hair. That means you must have red hair. Okay, so I have to start with the people who have red hair. Now, how many of those people who have red hair have green eyes? So of this total of red-haired people, okay, green eyes, okay, of the 4, 3 have green eyes. Okay, so what does that look like as a percentage? Okay, this is equivalent to asking what percent of people with red hair have green eyes. So 3 people out of 4 have this trait. Okay, so 3 people have green eyes out of the 4 that have red hair, okay, which is 0.75, aka 75%. Okay. What is the conditional relative frequency of having green eyes if you have black hair? So that means that I have to first look at all of the people who have black hair and then look at the number of the green eyes in the black hair data set. Okay, so how many people have black hair? Okay, so there are 9 people, right? Black hair. Go down, there's 9 people who have black hair. Out of the 9 people, how many have green eyes? Okay, so here's my black hair, here's my green eyes. Okay, well, only 1. Okay, so what does that look like as a percentage? So I only have 1 green-eyed person out of 9 people with black hair. Okay, 1 green-eyed person out of 9 people. So the percentage of having green eyes, if you have black hair, that means you must have black hair, and then there's only 1 chance of out of all of that 9 that you have green eyes. So 0.11 equals 11%. Okay. So part C says, does it appear that having green eyes has a dependency or at least an association with having red hair? Okay. Does it appear that having green eyes has a dependency with having red hair? Okay, well, the first thing we have to talk about is when you have green eyes, okay? So out of my total sample, does it appear that having green eyes has a dependency on, okay, red hair? Okay, well, let's look at what happens to my total sample if I'm going to compare it to red hair and green eyes as opposed to green eyes and another color hair, okay? So green eyes, how many people have green eyes? So looking around this thing, I have 5 people with green eyes, okay? So let's say 5 out of, how many people total am I looking at? 20 people have green eyes. Okay, what does that look like as a percentage? I get 5 out of 20. Okay, we've done this before, but 5 out of 20. times 100 is 25%. Okay, so what we're saying here is that out of 20 people, if you randomly surveyed 20 people in this class, there's going to be 20 that you're asking. 5 of them do have green eyes. Okay, but what happens when you're looking at somebody who has green eyes and having red hair? Okay, so now what we're looking at is a comparison between green eyes and red hair. Well, we've already found that in part A, green eyes if you have red hair. So in part A, there you are. In part A, green eyes with red hair occurs 75% of the time, okay? 75%, if I'm looking at these two numbers right here, this number is much larger than this number, right? So 75% is much larger than 25%, okay? So yes, we do see a dependency or at least an association with having red, if you have red hair, having green eyes, okay? Therefore, we'll say, therefore, okay, I'm just stating what it's asking me, okay? Alrighty, so now what we're going to do here is look at part D, okay? Is it more likely that a person with black hair has blue eyes or that a person with blonde hair has brown eyes? Okay, well, they're asking us an or statement. So we're going to do one on this side, one on this side. So on this side, I'm going to look at black hair has blue eyes, okay? So black hair, blue eyes. Okay. Okay. So first thing that you have to know is how many people have black hair. Okay, so is it likely person with black hair? So first you have to decide how many people have black hair. Okay, so out of black hair, here's my hair color, down, so out of 9 people, how many of those 9 people have blue eyes? Well, that's 3. Blue eyes and black hair, 3. So 3 out of 9. 3 divided by 9, okay, is 0.33 repeating times 100. I'm just going to do 33.3%. Okay, or that a person with blonde hair has brown eyes. Okay, so brown eyes, blonde hair. Okay, so the first thing I have to know is how many people have blonde hair. Okay, well, blonde hair, here's blonde out of, okay, so there's 7 people that have blonde hair. Okay, of that 7 people, how many have brown eyes? Well, brown eyes is right here, so 2. 2 out of the 7 people. Okay, which is 0.28, I'm going to round 6, okay, times 100. I'm going to round to 29. Okay, so which one of these is more likely? It is more likely that you have black hair and blue eyes as opposed to brown eyes and blonde hair. Okay, this is the last one. So a survey of 52 graduating seniors was conducted to determine if there was a connection between the gender of a student and whether they are going on to college. Based on this data, what is more likely? That someone going to college is female, okay, or that someone who is female is going to college? Okay. These may seem the same to you. These are not the same at all, okay? So what are you taking your total sample out of is what you have to decide. So for this first one, someone going to college, okay? This is your ultimate total. So out of all the people that are going to college, okay, is female. So let's do this one right here. Okay, and then I'm going to do this one right here. I guess, maybe. We'll see. We'll see what happens. Okay, so what is more likely? That someone going to college, okay, so going to college, how many people are going to college? Well, notice that going to college is a row and not a column. Columns go up and down. So going to college is across this way. So how many people are going to college? Well, 16 males are going to college, 13 females are going to college, and a total of 29 people are going to go to college. Okay. Out of that 29 people going to college, I want to know if they're female. Okay. So I'm going down my row or down my column now to look at gender. Female is this column right here, and going to college is 13. Okay. So I have 13 females going to college out of that total. Okay. So 13 divided by 29 times 100. Okay. I'm going to round it up to a whole number, 45%. All right, but the second one says, or someone who is female is going to college. So the first thing I have to look at is how many females I have. Notice how this is saying something different. This one says someone going to college, not someone who is female. This one says, okay, out of the total number of people going to college, how many of them are female? This one is saying someone who is female. So out of all of the females, how many is going to college? Okay, so someone who is female. So here's my female column. Okay, I'm going to look down at the total. Okay, so out of 22 females, right? 22 females in total in my sample. I have 22 of them. How many are going to college? Okay, well, not going to college is 9. Going to college is still 13. So I have 13 out of 22. So 13 divided by 22 times 100 is, I'm just going to call this 59. Okay. This is much higher. Okay. So what is more likely? Someone is female okay, so someone who is female is going to college is more likely, okay, because my percentage is higher. Alrighty, I know they're confusing. They take practice is all, and you will get practice. So you can head right to your Delta and have the most fantastic, beautiful day in the whole entire world. Goodbye.